Okay, here we go. 1024. So, when I do this problem, one of the things I want to do is I'm going to put an invisible number. I'm going to rewrite it as y equals, I'm going to put an invisible number 1 times 2 to the x. Okay, so what I did to help myself out is I put an invisible 1. And there's a reason I want that, okay? So if I use my calculator, and I'm going to say, for instance, let's just try different values. For instance, let's let x equal, say, -2, -1, 0, 1, 2, and 3. Okay. So if I let it be -1, I can just use my calculator. Okay, I'm just going to go, just let the calculator do the work. So I'm going to go 1 times 2 to the -2 power, and I get a 0.25. Okay, so graphing-wise, as far as a t-table, I'm going to have a point at -2 and then 0.25. So that's a point. -2, 0.25 is pretty small, but I'm just going to estimate it there, right? And then if I do -1, 1 times 2 to the -1 power, I get a 0.5, so I've got a point at -1, 0.5, and again, that's a point, right? Okay, I will. So that's a point, that's a value. So when I plugged in -1, I got 1/2, so I'll go -1 and 1/2 is about there. When I put in 0, now this is why I put the 1 in. Anything to the 0 power is 1. I'll say it again. Anything to the 0 power is 1. So this becomes, so 1 times 2 to the 0 power, that's 1. So 1 times 1 is 1. Now, these exponential graphs will always go through not 2, but the number in front of it. Okay, and we'll see those variations later, okay? Now, if I plug in 1, 2 to the 1 power is 2, right? If I plug in 1, 2 to the 1 power is 2. If I plug in 2, 2 to the 2 power is 4, right? 2 to the 2 power, so 2 to the 1 is 2, 2 to the 2 is 4. I know that. 2 to the 2 is 1, 2, 3, 4. And then 2 to the 3 power is going to end up being 8, right? 1, 2, 3, 4, 5, 6, 7, 8. It is exponential, right? We know that. We talked about that the other day. It is exponential. The only reason I use those, great question, is because those are the numbers right in the graph, right? Okay. Right. I want to use the numbers that are in the graph. I mean, I wouldn't want to use like 10 because it'd be off the graph, or -10, right? Okay. Just want the numbers that are around the center of the graph. Good question.
So if you just use those, you'll be fine?
Yeah, absolutely. Yeah, totally. So then I said, remember the asymptote. So here's what we talked about also. This graph is never going to reach 0, right? So there is what we call a horizontal asymptote right there, okay? So we have a horizontal asymptote at y equals 0, okay? Now, e to the x is the same way. In fact, if we use our calculator, okay, Tim, watch, I'm going to let x equal a -2, -3, oops, not -3, -2, -1, 0, 1, 2, and 3, right? And I'm going to plug those values in and get points, okay? And I'm just going to let my calculator do the work, okay? So my E button's over by my 4. So I'm going to go, all right, I'm going to go e to the -2, and I get an answer about 0.135, or 0.1. Let's go just 0.1. That's the best we can do. Now I can do e to the -1, about 0.3, about 0.4. E to the 0 is 1. I know that. Anything to 0 power is 1. Anything to 0 power is 1, okay? E to the 1 is about 2.7. You can check it on your calculator. E to the 2, I don't know what that is. Let's try it. E to the 2, about 7.4. And then 3, I've got e to the 3, e to the 3, and I get an answer of about 20. Okay, about 20.1, about 20, okay? So to graph this, okay, honey, you can see why I use these numbers, because -1, -2, 0, 1, 2, 3, those are the numbers around the middle of the graph, right? Yeah. So -2 and 0.1 barely could see it at all, right? Negative 1 and 0.4, again, you can barely see it. Super small, right? 0, 1, I got that one. 1 and 2.7 is about there. 2 and 7.4, 1, 2, 3, 4, 5, 6, 7.4 is there. And 320 is off my graph, right? So it looks almost the same, right? Pretty close to the same. Okay, got to remember my asymptote. Okay, we know that what happens is that it can never reach 0. So we're going to have a horizontal asymptote right there at y equals 0. Okay? Want me to let you catch up? Okay. So go ahead and catch up with that, and then we're going to do 2 to the negative x. We'll look at that one. Now when we flip it over the back, we're going to look at the opposites. We're going to look at their inverses, okay? All right, let's do, so same thing, Tim. I'm going to plug in negative 2. I'm going to plug in negative 1. I'm plugging 0. I'm going to plug in 1. I'm going to plug in 2, and I'll plug in 3, okay?
Is
And I'll
this
just,
what you start with?
yeah, and Tim asked a really question. He said, well, why? Why those, right? Hunter. I keep saying Tim. Hunter. This is, yeah, his uncle.
I'm not asking any questions.
No.
He's talking about-
So the reason I always use those, Bijou, is because those are the numbers that are right around the middle of the graph. And that's what I really want to see, right?
Okay, and we use them every time.
Yeah, yeah. So let's go. 2 to the, well, the negative 2 is 2 to the 2. I can do that. That's got to be 4, okay? Real quick, think about it. Put negative 2 in here, double negative. 2 squared is 4. 2 to the negative 1 is 2 to the 1, which is 2. Anything 0 power is 1. Now, 2 to the negative 1 is 1/2. 2 to the negative 2 is 1/4. 2 to the negative 3 is 1/8. Totally right. So if I graph those, let's see what those look like. So at negative 2, I'm at 4. Negative 1, I'm at 2. 0, 1, 2, let's see. 1, 1/2, 1/4, and 1/8, okay? All right, so this one is an exponential, but this one is decay, right? Those are growth. This one's decay. Okay, I want to draw in my asymptote for sure. It's got a horizontal asymptote here because it's going to approach that, but it's never going to touch that. So I get a horizontal asymptote at y equals 0. Okay. All right. Okay, exponential growth. We've done this. We've done this. We've seen these graphs. You guys agree? Seen these graphs before, right? What about its inverse? What would its inverse look like? Well, let's turn the page and look at its inverse. As soon as you're caught up, everybody caught up?
Yeah.
Okay, here's something you haven't seen. Log. Okay, so if I graph log of x, you can actually do that on your calculator, okay? You can actually do it. I can go, all right, go y equals, clear that. I can go log of x. You can actually graph it, and let's see what it looks like. Okay. Now, before I do it, though, I want my window to look like this window here, okay? Before I graph it, I want my window to look like this one. Does that make sense? So I'm going to make my window look like my graph. So I go to my window. Let's go to our window. And I'm going to go from negative 3 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to go to 11. So I'm going negative 3 to 11. I want my graph to fit this graph. Does that make sense? Scales by ones, okay? Negative, let's see, I got 1, 2, 3, 4, 5, 6. I'm going to go negative 6 to 1, 2, 3, 4 to 4, okay? So I changed my window. The window I want to use is the window that fits the graph I want to put it on. That makes sense. If I want to graph my graph here, let's make the calculator be the same size graph. I'll say it again. If I want to put my graph here, let's make the calculator have the exact same graph on the calculator, okay? So if I graph this, I go graph, boom, there it is. Huh. Now, what's going on? Are we looking? Right here. Does it touch right there? Does it touch right there? No, it doesn't. Because it's the opposite of these, because they're inverses. So instead of a horizontal asymptote, since they're opposites, they're inverses of each other, you're going to have a vertical asymptote right here. Okay? So it's going to be this shape, but it's going to be sideways, right? So instead of a horizontal asymptote, and now if you look, all of these graphs go through 1, don't they? All these graphs go through 1. All these graphs go through 1. So this graph's got to go through 1 also, but the x value, because remember, if it's an inverse, x's and y's change, right? So this graph looks like this. This is a logarithm graph, okay? That's a logarithm graph. Okay. So log base 2. Okay. So we want to graph this. So what we know is that exponents and logs, okay, write this down, exponents and logs are inverses. They're inverses of each other. They are. Okay? Because logarithms help us solve for exponents. They're opposites. So if they're opposites, let me turn the paper in a second. I'll wait till you guys are done. This is base 2, right? So I'm going to take these values that we had over here, and I'm going to switch them. Remember we had switched them? So I'm going to take these values. So my exponent will, if I had 2 to the x, those points were at -2 and 1/4. They were at -1 and 1/2. They were at 0 and 1. They were at 1 and 2. They were at 2 and 4 and 3 and 8. Okay? All right, those were the exponents, right? Those were the exponents, 2 to the x. But if we want the log of base 2, they're opposites. Remember how we did inverses? Remember what you did with the points? Remember what you did? Watch the hands. Remember how we did that? So if they're opposites, we're going to switch and make xy and yx, right? So if I wanted the log of this, I'm going to rewrite this as a 1/4 -2. I'm going to rewrite this as a 1/2 -1. I'm going to rewrite this as a 1, 0. I'm going to rewrite this as a 2, 1, a 4, 2, and an 8, 3. Okay, because these are inverses of each other. Remember how we did inverses of each other? So we switched the x and y's. Now, let's graph the log graph. Okay, we want to graph log base 2 of x. All right, we are going to graph these points. We're going to graph these points. So if I go 1/4 and 2, okay, so I go over 1/4 and go down -2. I go over 1/2, -1. I go over 1, 0, 2 over 2, 1. If I go 4, 1, 2, 3, 4, and I go 2. If I go over 1, 2, 3, 4, 5, 6, 7, 8, and 3. Now we know there's a asymptote right here. We know there's an asymptote right there, okay? And so this is our graph right here. Okay, now grab your journals. Grab your journals. Put the phones away. Journals. Let's grab our journals. Let's see how this looks, okay? Okay, it's actually not a bad day today. It's not too hard, so grab our journals, okay?